All right, so for this video, let's go over trigonometric ratios with radical functions. So we have to understand how to simplify these trigonometric ratios with radical functions, and we're going to use Excel to do that. So right here, right now, they want us to be able to pay attention to this angle E. Angle E has information across and on the hypotenuse, or opposite and hypotenuse. Opposite and hypotenuse will give us the sine function. So we have sine of E is equal to square root of 3 over 2. Then what we do is we take the sine inverse of a square root of 3 over 2, and that will give us our angle measurement E. So again, we're going to use our trusted calculator for this part, and we're going to go inverse sine square root of 3 divided by 2. Notice how I put it in. Notice I put parentheses around that 3 to make sure it doesn't mess with the division of 2. And then my answer is 60. So when I come back here, I'm going to go on screen and I'm going to type in 60. It's going to tell me I'm wonderful, right? I know you guys knew this, but Excel knows this now as well, right? So let's move on to the next question. All right, so now for this next question, we want to find the measurement of angle Z. Again, we look at Z, we have information opposite and information on our hypotenuse. How do I know it's the hypotenuse? Our hypotenuse is always opposite our 90-degree angle. So we have opposite and hypotenuse, and that would be so. So again, we're dealing with sine. So we have sine Z is equal to 3 square root 41 divided by 3 square root 82. Now, this is where it starts to get interesting, starts to get lovely. We cannot ever have a radical in the denominator. So let's go through the process of figuring out how to get rid of the radical in the denominator. All right, so on the whiteboard, what we want to do 3 square root of 41 divided by 3 square root of 82. So I'm going to do a couple radical problems here so we can kind of go through the process, right? So the only way to get rid of a radical in the denominator is to multiply it by itself. So we're going to multiply the numerator and the denominator by 3 square root 82. What's that's going to do? It's going to get rid of it in the denominator. So in the denominator, what we'll have is 3 times 3, which will give us 9 times 82. And I want to keep it like that because I don't know what's going to cancel from up top. So now from up top, I know 3 times 3 will give us 9. And then what we do have here is we have 41 times 82 underneath the radical. So now when they are the same number and they have the same number, then we could cancel out the radical because it's almost like we're squaring that number underneath a radical. However, when we have two separate numbers, we have to multiply it together underneath the radical. All right, now, so what I do know about the multiplication of these numbers is that 82 is 41 times 2, so I could break it down as 9 square root of 41 times 41 times 2, all divided by 9 times 82. So now, what I do know is these two numbers are going to come out as that single number. So right here, right now, what I will have is I will have 9 times 41 outside my radical, square root of 2. Then I will have 9 times 82, right? So now I know these two nines are going to cancel each other out. And we know that 41 times 41 41 times 2 gives us 82. So that means 41 goes into 82 two times. So this will cancel out. I'll get 1. This will cancel out, and I'll get 2. So now my ratio, my real fraction, will be square root of 2 divided by 2. So in order to answer this, what I would do is I would literally plug it in to my calculator as that fraction, square root of 2 divided by 2, right? So if I go back to trig to remind you, we're doing sine of z. So that means now sine of z after reduction, and let's put across there so we're not confused with it being 2, square root of 2 over 2. Now we do the inverse sine of square root of 2 divided by 2 is equal to our angle z. And this is probably going to give us an angle measurement of 45 or 60, one of those two. But let's actually go through the calculator to kind of see it. So we do sine, we do inverse, sine, square root 2, parentheses, divided by 2. And it gives us an answer of 45, right? So then I just go ahead and type my answer into the screen, 45 degrees, right? And it tells me good work, good job, right? But now here what I want to do is I want to go back to my whiteboard, because what I want to do is I want to be able to walk through another problem that could give you an understanding and give you help of these radical functions. All right, so for instance, let's say I have 3 square root of 10 divided by the square root of 4, right? So I can't have that radical in the denominator. So the only way to get rid of it is I want to multiply by square root of 4, right? And the reason why we do this is because square root of 4 divided by square root of 4 is 1. So it's just a technique we do in order to get rid of that radical in the denominator without really altering the function, right? Or altering the fraction. So now we'll have 3 square root of 10 times 4 divided by 4. Because remember, multiplying the square root of 4 times the square root of 4 is like squaring the square root of 4. And in order to get rid of a radical, you just square it, right? So now we have 3 square root of 40 divided by 4, right? And so now 40, can I break it down? I'm not sure. Let's find out. So I got 40. I know that's 4 and 10 is 2 and 5. So I can break this down because I do have a perfect square of 4. So that's 2 squared. So that's going to come out as a single digit, which is 2. So I'll have 3 times 2 square root of 10 over 4, right? So that's going to give me 6 square root of 10 over 4. And that 6 over 4 can be reduced because they both have multiples of 2. So that means this 6 will be a 3 and this 4 will be a 2. So then I'll have 3 square root of 10 over 2, right? So this is how you simplify radicals when it has a radical in the denominator. We want to get rid of that radical in the denominator, right? All right. I hope this video helps. If you have any questions, please let me know.